Good afternoon. Class, we are looking at Chapter 9, Systems of Equations and Inequalities. Here, Section 9.2, Systems of Equations, 3 variables. So we've already discussed systems of linear equations with 2 variables, and now with 3 variables. The objectives are solve systems of 3 equations in 3 variables, identify inconsistent system of equations containing 3 variables, express the solution of a system of dependent equation containing 3 variables. Recall, system of linear equations. A group of 2 or more equations is called a system of linear equations. They can be solved by graphic substitution or addition method. Types of system, a system of 2 linear equations in 2 variables can have 1 solution, no solution, or an infinite number of solutions. In the case of an inconsistent system, the system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. So they have equal slopes. M1 equals M2, but B1 is not equal to B2. If you solve it by the method of substitution or addition, you end up with a contradiction such as 0 equals 7, which indicates the system has no solution. The system is inconsistent. Consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different. They have different slopes. So the bottom line is M1 is not equal to M2. And here's an example of a graph and the 2 equations. Consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. Here's an example. If you solve for y, they become identical. M1 equals M2, B1 equals B2. And if you solve it by the method of substitution or addition, you get an identity such as 0 equals 0 that indicates the system has an infinite number of solutions. The equations are dependent. Solving graphically. To obtain a solution to a system of equations, graphically graph each equation and determine the point or points of intersection. By substitution, step 1, isolate a variable in one of the equations and solve for that. And step 2, substitute for that variable in the second equation. By the addition or elimination method, if necessary, rewrite each equation in standard form ax plus by equals c. If necessary, multiply one or both equations by a constant so that when the equations are added, the sum will contain only one variable. Number 3, add respective sides of the equations. This will result in a single equation containing only one variable. Solve the equation obtained in the previous step. Substitute the value found in step 4 into either of the original equation. Solve the equation to find the value of the remaining variable. Write the solution as an ordered pair. Check your solution in all equations in the system. This is what we did already. Systems of equations in 2 variables, everybody. And now, 9.2, systems of linear equations in 3 variables. Types of system. A system of 3 linear equations in 3 variables, similar to system of 2 linear equations in 2 variables, can have one solution, no solution, or an infinite number of solutions. The equation 2x minus 3y plus 4z equals 8 represents a plane in a space and is an example of a linear equation in 3 variables. The solution to this type of equation is an ordered triple of the form x, y, comma, z. One possible solution to this equation is 1, 2, 3, 5x minus 3y plus 4z equals 9. If you plug in 1 instead of x, 2 instead of y, 3 instead of z, that gives you an equation that holds true. So that's one possible solution, everybody. Types of solution sets, a consistent system of equations with a unique solution. A single solution if the planes intersect at a single point. That order triple is the solution to the system, looking like that. So you have one point that they all come together. A dependent system of equations, infinite number of solutions. If the three planes intersect along a line, the system has infinite number of solutions, which are the coordinates of any point along the line. So it has this line in common and therefore infinitely many solutions. If all three graphs are the same plane, the system has an infinite number of solutions, which are the coordinates of any point in the plane. So all three planes are at top of each other. Solving by any method results in a statement that is always true, such as 0 equal 0, an identity, a true state. Solving by addition method, substitution method. An inconsistent system of equations with no solutions. If all of the planes are parallel, the system has no solution. There's nothing in common. How about this case? Pairs of planes also can intersect, as shown like these two. However, because all three planes do not have a common intersection, the system has no solutions. So these two have a common line, these two have a common line, these two have a common line, but all three do not. And therefore, you obtain a statement that is always false, such as 3 equals 0. You get what is called a contradiction, everybody. So a contradiction. Determine whether 2 comma negative 1 comma 3 is a solution of the following system. So basically what you need to do, you have to plug in to check. In all three equations, replace x with 2, y with negative 1, and z with 3. So let's do that. X plus y plus z equals 4. So we put 2 plus negative 1 plus 3 equals 4. That's a true statement. So because it works with the first equation, you have to check with the second. 2x minus 2y minus z equals 3, we plug in. It works. That's a true statement. Because it works with the second equation, also you have to check with the third one. Minus 4x plus y plus 2z equals negative 3, so plug in the values. That's a true statement. Because 2, negative 1, 3 satisfies all three equations in the system, it is a solution for the system. Which means if it fails right here with the first equation, you don't have to check anymore. If it fails here, you don't have to continue checking. As long as it fails with one of the equations, you don't continue anymore. Systems in 3 or more linear equations are solved the same way systems of 2 linear equations are solved, by using either the substitution or addition, also known as elimination method. So the same methodology works, and we are going to look at an example here. X is given as -3, 3x plus 4y 7 minus 2x minus 3y plus 5z equals 19. So basically X is given, everybody. All you have to do, use this equation, plug in -3 and find the missing y. So equation 2, 3x plus 4y equals 7. Replace the x with -3. -9 plus 4y is 7. Move the -9. 16 divided by 4 is 4. Y is 4. And now we put that in equation number 3. We have the x, we have the y. We can find the missing z. -2 times -3 is +6, minus 12 is -6. Move this with 19 becomes 25. Divide by 5, you get 5. So the solution is as follows. The solution is the order triple, -3, +4, +5. The reason you have to check in this case, this was given, you use this one to get to y, you use this one to get to z. Otherwise, you really have to check it. There's no reason to check at this. Example 3, we are solving this system of equations. 3x plus 9y plus 6 is 3, 2x plus y minus z is 2, x plus y plus z equals 2. The methodology is that if we have a case such as the previous one, we try to do the substitution, but most of the time elimination works best. And the way it works is very simple. You decide to get rid of one of the variables. Which variable do you want to get rid of? See, it's easy to get rid of the z right here without doing anything. But if you decide to get rid of the y, that works here too. You multiply this one by negative, let's say. If you want to get rid of the x, that works out. You can multiply this one by negative, get rid of the x, and so on and so forth. But just the way it is, if you use equations 2 and 3, you can get rid of the z variable. So just don't make any changes. Write the two equations and you add them up. When you add up each side, here's what happens. These two cancel each other. And then these two add up to 3x, 2y, 4. It's that simple. Now, this creates an equation of two variables, x and y, and we call it equation number 4. Now, which equation has not been used yet from the original set? Equation 1. So you have no choice but to use equation 1. So this hasn't been used yet, must be used. Do you use it with the second or the third equation? It's up to you. You use it with the easiest one, okay? So eliminate z from equation 1 and 2. The reason we choose 2 is because number 2 has a negative sign here. So all you have to do, keep this one and multiply this one by 6. This becomes minus 60 and they can cancel each other. So you keep the first one, multiply this one by number 6. So the top one doesn't change. This becomes 12x plus 6y minus 60 is equal to 12. When you add them up, these two cancel each other. 15x, 15y, 15, and now we give it a number 5. There's a reason I do that. So what happens is that we have 3 variables, x, y, z. With this methodology, we get rid of one of the variables. So the dimension goes down from 3 goes to 2 because equations 4 and 5, if you put them together, now they have 2 variables instead of 3 variables. That's the concept. And if you want to get rid of the x, you multiply by negative 5 because this is 15x. If you want to get rid of the y, you multiply by, you have to multiply this one by 15 and this one by 2, one of them negative. So it's better to get rid of the x so you don't have to multiply both of them. The first equation we multiply by negative 5. So we just write this second one, which is equation number 5. This one, when we multiply by negative 5, we get negative 15x minus 10y equals negative 20. These two cancel each other. This is 5y. This is negative 5. Divide by 5, y becomes negative 1. So we got one of the variables. We are going to use, so this is step 3. We are going to use one of the equations in equations 4 or 5 because they have 2 variables to find the other variable, meaning x. So we can use 4 or 5. Let's use 4. 3x plus 2y equals 4. This is equation number 4, everybody. Replace the y with negative 1. You get negative 2, move it, you get 6, and 3x equals 6, x equals 2. We have 2 of the variables. We have x and y. To find the z variable, you go to one of the original equations. The easiest would be the third one. Z becomes 1. It's a good practice to write them as x, comma, y, comma, z, 2, comma, negative 1, comma, 1. And you must check. Okay. What do you check? You don't check it with the third one because you use that one to get to the last variable. You check it with this one. 3 times 2, 6. 9 times negative 1, negative 9, they add up to negative 3. 6 times 1, positive 6, they add up to 3. I'll leave it for you to check with this equation. Make sure you check your work, everybody. Has to be checked. Geometric interpretation. The following is a geometric interpretation of the solution 4, 5, 3. So you have the x-axis, the y-axis, the z-axis. So it goes 4 units to the positive side of x, 5 units along the positive side of y. Remember, negative would go in here, and this one to the left. Z above, 3 units above, negative would go down. So this is the point. So it's a three-dimensional figure, if you will. Example 4, we have, again, a system of 3 equations. X plus y plus z is 6, x plus 2y minus z is 2, x minus y plus 3z equals 8. And we have to pick two. We have to pick 2 equations from the set of 3 and combine such that one equation in two variables is obtained. And normally you pick the one that really is easy to deal with. Okay, class. In this case, actually, you can get rid of any of the variables, makes no difference. Okay. But I mean, for example, if you use 1 and 3, you can get rid of y. Okay. If you use 1 and 2, you can get rid of z. So that would be the easiest. We're going to go with the first and the second one to get rid of the z, just the way it's given. Number 1 and number 2. I put the equation numbers so we know what we are dealing with. So we are going to add them up. These two cancel each other. These two add up to 2x. These two add up to 3y. And these two add up to 8. And this new equation, we call it equation number 4. Okay? So we call it equation number 4. Now, must select equation 3 because it hasn't been used. And one other equation, any to eliminate the same variable, use 2 and 3 to eliminate these. So what is important is to understand that you have to use the one that hasn't been used yet. 3 must be used. And so, because this guy has a negative z, it's easier than 1. Okay? That's why if you use 1, there's nothing wrong with that. So we're going to use 2 and 3. So 3 is fine. Number 2, if we multiply by 3, this one repeats. This one is now 3x plus 6y minus 3z equals 6. You add up each side. These two cancel each other. These two become 4x. These two become 5y. These two become 14. And we call it equation number 5. Now, equation number 4 has 2 variables, x and y. Equation number 5 also has 2 variables, and we're going to put them next to each other. So solve. So we went from a 3 by 3 to a 2 by 2. Solve the system of 2 by 2, the 2 by 2 system of equations 4 and 5. That's what we are going to do. So it's pretty straightforward. Now, how do we do that? You always take the least number of steps. Notice this is 4, this is 2. If I multiply this one by -2, I can cancel out the x. If I want to cancel out the y, this one I got to multiply by 5, this one by 3, and one of them has to be negative. So easiest one, multiply this one by -2. So what happens? This one you repeat it. This one becomes minus 4x minus 6y equals minus 16. Remember, when you multiply both sides of the equation by the same number, not 0, not 0. You are not changing the equation. Essentially, you're dealing with the same equation, everybody. And that's important to understand. The equation is not being changed, essentially. The essence of the equation remains unchanged. And so what happens? You add up these two, they cancel each other. You add up these two, you get negative y. And you add up these two, you get negative 2. If negative y is negative 2, then y must be positive 2. So we got one of the variables, and equations 4 and 5 have only two variables. We're going to put it into the 4 or 5 equations, makes no difference. So if I put it here, I get 2 times 2 is 4. I'm sorry, 2x, my apologies, plus 3 times 2 is 6. So 2x plus 3 plus 6 is 8. Subtract. You get 2 divided by 2, and x becomes 1. Now what? Now we go back to one of the original equations, and we find the missing variable. We already have x, we already have y. What is missing is z, and we are going to use one of the original original equations. For example, this seems to be the easiest. Replace the, replace the x with 1, y with 2. Move it, subtract it, and z becomes 3. And you're going to put 1, 2, 3 as the order. It's very straightforward. I hope everybody is okay with that. Now, as always, you have to check. So what do? You put that into other equations. For example, number 2. Okay, of course, you have to check with both of them. Don't ever take a chance. X is 1 minus 2, 1 x. Oh, I was looking at the third one, but that's fine. 2. X is 1. 2 times 2 is 4. They add up to 5 minus z, which is 3. 5 minus 3 is 2. X minus y, 1 minus 2 is negative 1, plus 9. Negative 1 and 9 is positive 8. So we quickly check, everything works, and that's fine. And that's the idea. Always check. It doesn't take long when you are checking. And it's definitely worth it. All right, we are ready to move on. We're going to solve this number 1x minus 3y plus z equals 1. Number 2, 2x minus y minus 2z equals to 2. And number 3, x plus 2y minus 3z equals negative 1. Again, I like to give them numbers. It's easy to work with it. So let's eliminate one of the variables. There are 3 variables. We want to go from a 3 by 3 to a 2 by 2. So, for example, we can eliminate x from equations 1 and 2. If we decide to do that, that means you are going to repeat number 2 without any changes. You're going to multiply number 1 by negative 2 because you want to get rid of the x variable. Okay. What happens when we do that? Number 1, this one doesn't change. Number 2, this one becomes minus 2x plus 6y minus 2z minus 2. So equation number 1 is multiplied by negative 2. Let's, in fact, do this. Multiplied by negative 2. Okay. So what happens? These two cancel each other. You get 5y minus 4z equals 0. We have 2 variables, y and z. We are going to eliminate x from the equation we have not used yet, which is equation number 3 and either 1 or 2. So eliminate x from equation 1 and 3. So how do we do that? Let's keep this unchanged and let's multiply this one by negative 1. We get minus x minus 2y plus 3z equals positive 1. Okay. When we put them together, these two cancel each other. This is negative 5y, positive 4z equals 2. And that would be equation number 5. Here's the reason I did that. Take a look at the third step. I'm going to put those two together to eliminate something from them. And when I put them together, the y's cancel out, right? These two cancel out. The z cancel out too, but the right side becomes 2. So what you're dealing with 0 equals 2, which is a false statement. That makes it an inconsistent system with no solution. On the other hand, if it was an identity, it would make it a true statement with an identity and a dependent system with infinitely many solutions. That's how things work, everybody. Let's look at an application. Jay borrows $25,000 to pay for a remodeling. He borrows some of the money at the bank that charges 8% interest. At the second bank, he borrows $2,000 more than 1/2 the amount borrowed from the first bank. The interest rate at the second bank is 10%. The balance of the 25,000 is borrowed from a third bank where 9% interest is to be paid. The total annual interest Jay pays for the 3 loans is $2,220. How much does he borrow at each rate. So let's see how that is going to work out. So you have to set up a table. You have the banks. So bank rate, amount borrowed, interest. Okay. So bank number one, the interest is 8%. Bank number two is 10%. Bank number two is 9%. So 8%, 10%, and 9%. The 8%, okay, we don't know any of those amounts, okay? So what we know is that we have $25,000 total. So how much did we borrow? The total amount is $25,000. That we know. So $25,000 goes there. The total amount that was borrowed is listed here. The total amount of interest, and the amount is X, Y, Z, by the way. We don't know how much we got, but we have the first equation, X plus Y plus Z is equal to 25,000. The amount of interest over the course of 1 year, I'm going to write the formula reminding you that I equals PRT, everybody. T is 1 year. Why is that? Because it says annual interest rate. Therefore, 0.08 times x times 1, we don't mention it anymore. So this is 0.08x. This is 0.1y. This is 0.09z. And we know this interest is $22,220. So here's the equation number 6. Equation number 7, we can write it right here that it says at the second bank, he borrows 2,000 more than 1/2 the amount borrowed from the first bank. So the amount that we borrowed here, Y, is 2,000 plus half of the first bank. So this is 1/2 X plus 2,000. That's this equation. So take a look at the one I put it in red in essence, okay, or purple. And this gives us the third equation, 0.08x plus 0.10y plus 0.09z is 2240. So these are the three equations. To solve this, first and foremost, let's get rid of the fraction, and that means, and then we combine them. That means if I multiply this by 2, I get 2y equals x plus 4,000. And if I want to put it in the format of, let's say, the first equation, I bring the variables together, I move the x, I get minus x plus 2y equals 4,000. You can get rid of this one also by multiplying by 100. So we can multiply by 100 to get rid of the decimals. You don't have to do that, but so this becomes 8x, this becomes 10y, this becomes 9z. And now we have three equations to work with. Let's write those three equations. Okay, these are the three equations from the previous page. We're going to continue working on them, and we have minus x plus 2y equals 4,000 here as the second equation. Remember, you can do by any method you want. Always go with the one that takes the least number of steps. Look at the second one. It has x and y. So if you use the first and the third one to get rid of the same variable, namely z, also you can combine it with number 2 and solve it. So what do? We decide to get rid of the same variable, which is z. So this one has 9z. If I multiply this one by, so look at 9. So I need negative 9 here, times negative 9. So use equation 1 and 3 to eliminate z. And we're going to multiply by negative 9, which means you're going to repeat number 3 unchanged. This one, 9x, becomes minus 9x, minus 9y, minus z, 9 times 25, 225, so minus 225,000. And number 3, you just repeat it unchanged. So what happens? These two cancel each other. These two give us minus x plus y minus 3,000. And that, we call it equation number 4. We are going to combine equations 2 and 4. And we're going to eliminate one of the variables. And it's easier to just change the sign for x here or here to get rid of it. Doesn't matter which one. So let's multiply. So we're going to write this, and we're going to multiply this by negative 1. And this becomes x minus 2y minus 4,000. So these two cancel each other. These two become negative y. They add up to negative 7,000, which results in y being 7,000. Now, clearly, we rather use original equations to solve for a variable. So if we go with number 2 and replace what we just found, so 2 times 7 is 14,000, subtracted. You get minus 10,000. Minus x is minus 10,000. Positive x is positive 10,000. We use the first equation to find the z. These two add up to 17k or 17,000. So minus 17k or 17,000. Z becomes 8,000. Which means Jay borrows $10,000 at 8%, $7,000 at 10%, 8,000 at 9%. And you really have to go back to those original equations of the previous page and check them out to be on the safe side. Okay. First of all, the first and easy equation, they must add up to 25,000. Okay. I mean, just the second equation again is easy. Half of this, half of x is 5,000 plus 2,000 is 7,000. The 8,000, you want to put it into 0.08x and 0.1y and 0.09z, all of them, to make sure that works. And it's 0.08 times 10,000, 0.1 times 7,000, 0.09 times 8,000, and they should add up to $2,220, which was the amount of interest, and that's not a big deal. So if you multiply these two, you get 800, these two, you get 700, these two, 9 times 8, you get 720, and if you add them up, you get $2,220. At the movie theater, Kyle buys 1 popcorn, 2 drinks, and 2 candy bars, all for $12. Of course, this is years ago. Robert buys 2 popcorns, 3 drinks, and 1 candy for $17. Lee buys 1 popcorn, 1 drink, and 3 candy bars for $11. Find the individual cost of 1 popcorn, 1 drink, and 1 candy bar. Now, rather than X, Y, and Z, let's go with P is the cost of popcorn, D is the cost of drink, C is the cost of candy. Sometimes using the initials makes it easier, everybody. It's really a good practice to set up a table. So Kyle spends $12, Robert spends $17, Lee spends $11. Okay. Popcorn, just for the sake of argument, Kyle, 1, drinks 2, candy bars 2. Robert, popcorn 2, drinks 3, candy bar 1. Lee, popcorn 1 drink, and 3 candy bars. So we throw in those numbers: 1, 2, 3, 1, 2, 2, 2, 3, 1, 1, 1, 3. So how much would Kyle pay? 1 times P plus 2 times D plus 2 times C equals 12. Robert would pay 2 times P, 3 times D, 1 times C equals 17. And Lee pays 1 times P, 1 times D, 3 times C, and that equals 11. That's how we set up those equations, everybody. The most important part, and probably the hardest part, is this one. Solving it shouldn't be a big deal. So you decide to get rid of one of the variables and take it from there. So if we look at the way they set up, you can get rid of any of them, actually, D, P, even C, because all of them seem to be easy, including this one has coefficient 1, this one has coefficient 1, this one has a coefficient 1. So, but if you use 1 and 3, everybody, 1 and 3, because both of them have P, just all you have to do, multiply one of them by a negative sign. So if I multiply one of them, for example, this one by -1, I get minus P, minus D, minus 3C equals minus 11, and the first one doesn't change. So when we put them together, these two cancel each other. These two add up to D, these two add up to minus C, these two add up to positive 1. We call it equation number 4. Which one hasn't been used yet? Number 2 hasn't been used yet. Must be used. Must be used. Does it matter if you use 1 or 3? No. So we use it with 1, let's say. 2, we have no choice because it hasn't been used. Otherwise, it will not be correct. So this, we are not going to change it. We're going to repeat that. This one, we're going to get rid of the P, the same that we got the same variable that we got rid of here. So we multiply this one by -2. So we get minus 2p minus 4d minus 4c equals minus 24. Combine them. These two cancel each other. These two add up to negative d. These two add up to negative 3c. These two add up to negative 7. And we call it equation number 5. Now we're going to put equations 4 and 5 next to each other. And we are going to get rid of one of the variables. Clearly, you don't have to do anything. Just add them up and the d drops, right? This would be minus 4c. This would be negative 6. And so divide by negative 4, you get 1.5. Now, if c is 1.5 and you go to equation 4, d minus what? Minus 1.5 is 1. So d becomes 2.5. Equation number 4 gives us the value of d. So d minus 1.5 is 1. So d must be 2.5. Now we go with one of the original equations. Probably this one is easier because both of them have coefficient 1. So p plus d plus 3 times 1. So plus d plus 3c equals 11. D is 2.5. 3 times c, 1.5. So d is 2.5 and plug it in. So 4.5 and 2.5, they add up to 7, subtracted from 11, p becomes 4. And you have to check with all three to be on the safe side. In fact, you don't have to check with number 3 because number 3 was used. Check with the first and the second one to make sure you have the correct answer, and you're done.